Welcome students to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem 16 from chapter 1, the fundamental of physics by Resnick, Halliday, and the problem says that the time standards are based on atomic clocks. A promising second standard is based on pulsars, which are rotating neutron stars, highly compact stars consisting only of neutrons. Some rotate at a rate that is highly stable, sending out a radio beacon that sweeps briefly across Earth once with each rotation, like a lighthouse beacon. So Pulsar PSR 1937 plus 21 is an example. It rotates once every this much millisecond, and it is plus minus 3 milliseconds, where the trailing plus minus 3 indicates the uncertainty in the last decimal place. It does not mean plus minus 3 milliseconds. So this plus minus 3 is the uncertainty in this last digit, that is 5, right? So this 5 is the digit, the 14th digit after the decimal place, right? This is 3, 6, 9, 12, 13 and 14th. So in part A, we are asked to find how many rotation does PSR 1937 plus 21 make in 7 days. So in the problem statement, it is said that this PSR 1937 plus 21 pulsar rotates once every this much second. So we can write that one rotation is equal to 1.557806,448,87275 and plus minus 3. So now in 7 days, for part A, we have to find how much rotations in 7 days. How many rotations make in 7 days. So we can write that 7 days. Remember that this 7 days, this 7 is given in terms of 3 significant figures. So our answer need to be up to 3 significant figures as well. So this is 7.00 days. This is equal to, so first of all we have to convert this days into seconds, since this one rotation is given in terms of seconds, right? So this is millisecond. Let me write that this is milliseconds, or we can say that milli is 10 raised to the power minus 3, so we can say that this is multiplied by 10 raised to the power minus 3 seconds. So this one rotation is given in terms of seconds, so we have to convert this days into seconds. So 7.00 days. So we have to multiply it by a fraction, and we need to cancel out the days. So 1 day is 24 hours, and again we want to cancel out the hours. So 1 hour is 3600 seconds. So this will cancel out, this days will cancel out with day, hours with hour, and we will be left with seconds. Now we want to convert this days into rotations, so we know we want to cancel out this seconds as well, right? We want to have the rotation at the end, right? So this will be, we have to multiply it by, we need to cancel out the seconds, right? So the seconds should be in the denominator and the rotation should be in the numerator. So one rotation is equal to this much milliseconds, right? So this is 1.5557,806,448,872,75 into 10 raised to the power minus 3. This is into seconds. So second will cancel out. So now we are left with just numbers and this rotations, right? So this is 7.00 into 24 divided by 1 is 24, multiplied by 3600 divided by 1 and multiply by this ratio, right? So let's multiply it directly in calculator. So that is 7 multiplied by 24 multiplied by 3600 multiplied by that fraction 1 divided by 1.557 806 448 872 75 multiplied by 10 raised to the power minus 3. So this gives us, let me write that this is equal to 388,238,218 approximately this number of rotations. So since this 7 days is given in terms of 3 significant figures, so we have to convert this into 3 significant figures. So for that, if I count these digits, so this is 1 2 3 4 5 6 7 8. So currently the decimal number is here. So if you want to transfer this decimal place until here, right, so we need to divide this number by 10 raised to the power how much? This is 1 2 3 4 5 6 7 8, right? So we need to multiply and divide this number by 10 raised to the power 8, right? So let me write this like 10 raised to the power 8 multiplied by 10 raised to the power 8 rotations. So if we divide this answer by 10 raised to the power 8, so we will get 3.88. So we will write until 3 significant figures. So 3.88 into 10 raised to the power 8 rotations. So in 7 days, this Pulsar PSR 1937 plus 21 will make this much rotations. So this is the solution of the part A. Now in part B, it is said that how much time does the pulsar take to rotate exactly 1 million times. So now 1 million is 10 raised to the power 6. 1 into 10 raised to the power 6 is 1 million, right? So now 1 multiplied by 10 raised to the power 6 rotations, right? Now it is given that 1 million times rotation, right? So now we are given rotations and we need to convert this rotations into time, right? How much time does the pulsar take to rotate 1 million times, right? So we need to convert this rotation into seconds, since we are given the conversion between rotation and seconds. So now 1 multiplied by 10 raised to the power 6 rotations. So we need to multiply it by a fraction in order to cancel out these rotations. So rotation need to be in the denominator and the seconds need to be in the numerator. So one rotation is equal to this much seconds, right? So again we need to write this number. This is 1.557 806 448 into 10 raised to the power minus 3 seconds. So rotations will cancel out and we will get our answers in second. So this is 1 multiplied by 10 raised to the power 6 multiply by that number divided by 1 will give us that number. So this is 1.557 806 448 872 75 into 10 raised to the power minus 3. So this gives us 1557.806 rotations. So now 1 million rotations is equal to this much seconds. This is not a rotation since the rotation is cancelled out, so this is seconds. Now in part C, we are asked to find the uncertainty. What is the associated uncertainty in this 1 million rotation in 2 seconds, right? So we can say that in one rotation we have the uncertainty of plus minus 3 in the last digit, right? So we can say that the last digit is the 14th digit. So this means that the uncertainty is let's say represented by u. So the uncertainty in one rotation is 0.000. We need to write 13 zeros, right? This is 9, 10, 11, 12, 13, and then this. So this is plus minus this much millisecond is the uncertainty. So now if I count all these, this is 3, 6, 9, 12, 13, 14. So if you want to bring this decimal place until here, so we need to write it like this. This will be 3 into 10 raised to the power minus 14 milliseconds. And if you want to convert it into seconds, so this is 3 into 10 raised to the power minus 14, and milli is 10 raised to the power minus 3. So this is minus 14 into minus 3. So this uncertainty is 3 into 10 raised to the power minus 17 seconds in one rotation. Now in 1 million rotations, how much is the uncertainty? So we can say that the capital uncertainty, the capital U represents the uncertainty in 1 million rotations. So this will be 1 multiplied by 10 raised to the power 6, that is 1 million, multiplied by 3 multiplied by 10 raised to the power minus 17. So this is 1 multiplied by 10 raised to the power 6 multiplied by 3 multiplied by 10 raised to the power minus 17. So this gives us 30 into 10 raised to the power minus 12, or we can say that this is 3 into 10 to the power plus 1 into 10 raised to the power minus 12. This will be in seconds, remember. So this is 3 into 10 raised to the power minus 11 seconds. This is plus minus, right? This is uncertainty, so this is plus minus. So the total uncertainty in the final readings, that is 1 million rotations, is plus minus 3 into 10 raised to the power minus 11 seconds. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy for such more problems related to fundamental of physics by Resnick Halliday.